segment, we will add or subtract fractions that have the same denominator. We'll also talk about least common denominator, and we'll talk about equivalent fractions. We'll practice finding equivalent fractions. By the way, since we're beginning with adding or subtracting fractions with the same denominator, let's talk about how we might do that, and then we'll look at a rule that we'll use. But let's suppose you have, say, 1/3 of a pie, and then let's add to it 1/3 of a pie. Doesn't it make sense you have then 2/3 of a pie? So if you think about that a moment, 1/3 plus 1/3 is 2/3, and that's how we add fractions with the same denominator. We add the numerators and we keep that same denominator. So let's look at the following. Adding or subtracting like fractions, and those are fractions with the same denominator. If A, B, and C are numbers, and B, notice B is in the denominator, so B is not 0, then A over B plus C over B is equal to A plus C all over B, and also A over B minus C over B is equal to A minus C all over B. In other words, to add or subtract fractions with the same denominator, add or subtract their numerators and write the sum or difference over the common denominator. So let's practice doing that. I am adding fractions. The first thing you need to do is look at the denominators. They're either the same or they are not. Since I do have the same denominator, then it's very simple. It's just numerator 5 plus numerator 2 all over a common denominator, in this case 11. 5 plus 2 is 7, 7 over 11, and we do need to always check to make sure our result is written in simplest form. 7 and 11 have no common factors other than 1 or -1. So there is my sum. Let's practice this for a few minutes and remember what we are doing. We are adding or subtracting fractions with the same denominator. So here the operation is subtraction, and you need to think then for addition or subtraction the denominators must be the same. So it's subtraction. It just so happens that the denominators are the same. So that is numerator, in this case minus numerator, all over a common denominator. 10 minus 4 is 6. And I have 6 over 11. Is this in simplest form? The answer is yes. 6 and 11 have no common factors other than 1 or -1. Now, before I continue, I want to review something very important, and you've got to remember this when working with fractions, and that is the following. Let's suppose I have, say, -10 over 5. And think of that as division. Think of the fraction bar as division. What is -10 divided by 5? -10 divided by 5 is -2, because -2 times 5 is -10. Also now, what if I place that negative sign in the denominator? What is 10 divided by -5? Well, 10 divided by -5, that is also -2, because -2 times -5 is +10. Then, finally, let me place the negative sign simply in front of the fraction. In other words, negative, and then we have the fraction 10 over 5. What is 10 divided by 5? It is 2, so I'll rewrite that negative sign, and then I'll write the 2. Now, because each of these equal -2, they are all equivalent. This is equal to this, which is equal to this. So notice these three. Basically what we're saying then, what we've just shown, is that you can take the negative sign, if it's in the numerator, you can place it, if you'd like, in the denominator, or you can place it in front of the fraction. They are all equivalent, and you need to use this often, so remember that. Let's look at this in general. In general, the following is true. Negative a over b is equal to a over negative b is equal to negative a over b, and of course this is as long as b is not equal to 0. Keep that in mind as we work with fractions. Let's again, in this case, add two fractions. I'm adding two fractions, so immediately look at the denominators. The denominators are the same, so, by the way, this is negative 6/20. I can write it as negative 6 over 20, if you'd like me to take a step and just show you that. And so what does this become as we add? It is numerator plus numerator over that common denominator. But here's an example where the movement of the negative within a fraction is very helpful. Notice I moved it from the front to the numerator, and that is certainly appropriate and okay. So here we have negative 6 plus 1. Negative 6 plus 1, that is negative 5 over 20. And now what do? We see if the numerator and denominator have any common factors, and in fact they do. If you are more comfortable, once again, the negative is in the numerator. Remember, you can move it in front of the fraction, and then I'll write 20 as, say, 5 times 4, because I know 5 and 20 have a common factor of 5. 5 divided by 5 is 1. Same thing here. And so I have negative 1 over 4. Negative 1 over 4. There is my result when I add those two fractions. Let's continue. Just be very, very careful, and it does help if you write neatly. Let's suppose I have, let's put a variable in here, 7x over 16 minus 15x over 16. So we have fractions. The first thing you do is notice the operation is subtraction, and immediately then go to the denominators. The denominators are the same, so it is simply numerator minus numerator over that common denominator, and there we have it. So what is 7x minus 15x? Those are like terms. 7 minus 15, that's negative 8x over 16. And now what? Now we simplify. If you'd like, you can put the negative in front, and in the numerator I do have 8 times x. In the denominator, 16 is 8 times 2. Thinking about those common factors, common factor of 8. So what is my result? It is negative 1 times x. I can just write that as x over 1 times 2, or 2. There is my result when I subtract these two fractions. Let's try that one more time, and then we'll move on to some algebraic expressions. Let's suppose I have, say, 9 over 12 minus 7 over 12 minus 10 over 12. I'm subtracting, same thing. Look at the denominators. The denominators are all 12, so it is first numerator minus second numerator minus third numerator all over that common denominator. And there we have it. Let's now simplify in the numerator. 9 minus 7 is 2. 2 minus 10 is negative 8. So I have negative 8 over 12. How do we simplify? If you'd like, move that negative in front. And then let's see, 8 and 12, you can write the prime factorization of each, but I know 8 and 12 have a common factor of 4, so I'll write 8 as 4 times 2, and I'll write 12 as 4 times 3. Don't forget that negative, and then I'll divide out that common factor of 4, and then I have then 2 over 3. So my result is negative 2/3.